Okay, now we're going to talk about section 2.4, which is operations of functions, and in this college algebra lecture series. So just like there's 4 mathematic or arithmetic operations, there's actually 4 operations with functions we can talk about. We can talk about the sum function, which actually is a function that represents the sum of 2 functions f and g. We can talk about the difference function, which is a function that represents the difference of 2 functions. We can talk about the product function, which is a function that represents the product of 2 functions. And we can talk about the quotient function, which is a function that represents the quotient of 2 functions, as long as the denominator is not equal to 0. So let's say that, let's do the sum example here. Obviously, you've got to have a couple of functions to work with for me to show you this. So let's say that f of x is 2x plus 3 and g of x is x squared plus 5. And I want you to find f plus g of x. Okay, well, f plus g of x, all you do is take f of x and add it to g of x, and then of course combine any like terms. So if I add these two together, I get x squared, and then 2x, and then 3 plus 5 is 8. So this function, x squared plus 2x plus 8, is the function f plus g. So that would be the sum function of those 2 functions. Now the difference function of those 2 functions, you would just subtract. So if you wanted the difference function of f minus g, you would simply, to get that, you would simply take the f of x minus g of x. Now all that's going to give me is minus x squared, and then I'm going to have 2x, and then 3 minus 5 would be minus 2. So that would be the difference of those 2 functions. Okay, and actually I wrote it down here as a single function, but anyway, f minus g function is just minus x squared plus 2x minus 2. Then I could also do the product of these 2 functions. So the product function would actually be the product of these 2 binomials. And you know how to FOIL, and so that's all we're going to do. We're just going to FOIL 2x times x squared is 2x cubed, 2x times 5 is 10x, 3 times x squared is 3x squared, 3 times 5 is 15. And then you add like terms together, but there's no like terms, so that would be, the product function would simply be f times g of x would simply be 2x cubed plus 3x squared plus 10x plus 15. And then finally, the last one we're going to do would be the quotient function. And the quotient function, there's not much we can do with it. We just take the first function divided by the second function to get the quotient function. And so f over g of x is the function 2x plus 3 over x squared plus 5. You can also do these with values as well. So let's say I gave you these 2 functions. F of x equals 1 minus x squared and g of x equals x minus 3. What if I said find f minus g evaluated at 1? Well, that would be the f function evaluated at 1 minus the g function evaluated at 1. Well, the f function, if you plug 1 into this function, you get 1 minus 1. And then the g function, if you plug 1 into this function, you get 1 minus 3. So basically you're going to get 0 minus negative 2, which is 2. Now what's interesting here though is you could actually come up with this f minus g function and take that new function, and if you plug 1 into it, it would actually give you the same value. It would give you 2 as well. So you could do it either way. You could either just do f of 1 minus g of 1, or you could come up with the f minus g function like I came up with up here, and then you could plug 1 into that function and get 2 as well. Alright, what about f divided by g evaluated at 0? Well, that would be f of 0 over g of 0. So I evaluate the f function at 0, so that would just be 1 minus 0. I evaluate the g function at 0, and I get 0 minus 3. So on top I get 1, on bottom I get minus 3, and then that's going to give me minus 1/3. Now again, you could actually just get the f over g function and evaluate it, which would be, that would just be this function over this function. And then you could plug 0 into that new function f over g, and you'd still get minus 1/3. We'll finish up this section with composite functions. And composite functions, they have this funny little circle that denotes the composite function. And all this means is, when you see this little circle, it just means f is evaluated at g of x. Remember how you can evaluate a function at an expression? Well, that expression could be another function. So for example, let's say I gave you two functions, 3x minus 1 and x squared plus 2x. And I said find f evaluated at g of x. Well, what that means is, it means you're supposed to evaluate, as it says up here, you take f and you replace x with g of x. So basically what I'm going to do is I'm going to take this g of x, x squared plus 2x, and I'm going to plug it in right there for x. So that's going to give me 3 times, and then here's the g of x function, x squared plus 2x minus 1. And then you just simplify it. 3 times x squared is 3x squared, 3 times 2x is 6x, and of course you just carry the minus 1 along with you. Okay? So that's how you do f of g of x. Now you can turn it around and you can do g of f of x. To do g of f of x, you actually go the other way. You take this f function and you go over here, and everywhere you see an x, you have to replace that x with whatever that f function is. So in this case, instead of x squared, I would have to replace x with 3x minus 1. So I'd have 3x minus 1 quantity squared. And instead of 2x, I would replace the x with 3x minus 1, and I'd have 2 times 3x minus 1. Well, you know how to square a binomial, so that's easy. 9x squared minus 6x plus 1, and then you distribute the 2, and you get 6x minus 2, and then you collect like terms. This x, the 6x and the minus 6x cancel, so you get 9x squared, and 1 minus 2 is negative 1, so you just get 9x squared minus 1. Now you can also compose f with f. So might seem a little strange, but you can. Or I could have composed g with g, but let's say we want to compose f with f. Well, f with f, that simply means that you're going to take this f function and you're going to put it in wherever the x is. So basically, I'm going to take the f function and I'm going to evaluate it at itself. I'm going to evaluate it at 3x minus 1. So go back up here and look. If you do that, you simply take this x and replace it with 3x minus 1. So if I do that, I get 3 times 3x minus 1, and then I have the minus 1 that goes along with it. Well, that's 9x minus 3, and then the minus 1. So that's going to be 9x minus 4. Now, if you wanted to, you could do f of g at 2, like at a number instead of x. If you do that, then what you're doing is you're taking the f function and you're going to evaluate it at whatever g of 2 is. Now notice I put an 8 here. Now let me show you how I got 8. Go over here and let's evaluate g of 2. And you'll see that's how I got the 8. Okay, so right here's g, right? So just plug 2 in here, and what I get, 2 squared is 4, 2 times 2 is 4, 4 plus 4 is 8. So that's how I got 8. Okay, so g of 2 is 8. So now that I know g of 2 is 8, I know I'm evaluating this function at 8, which would be 3 times 8 minus 1. So that's 24 minus 1, which is 23. Take a look at this. Up here, we determined that f of g is actually this function right here. So if I evaluated that function at 2, wouldn't that be the same as what I did over here? F of g of 2? Well, see what happens. If I plug 2 into that function, I get 3 times 2 squared, which is 3 times 4, plus 6 times 2, which is 12, and minus 1. So basically, I get 12 plus 12 minus 1, which is 23, which is what I should get. So that's just another way to get it. So if you already know what the f composed with g function is, you could just plug the 2 into that function. Okay, now to wrap this up, I want to show you a couple of functions here, 3x minus 1 and 1/3 x plus 1/3. I want to show you what happens when I compose them. Let's compose f with g. So I'm going to take this x and replace it with this function here. So instead of 3x, I'm going to have 3 times that function, and then of course the minus 1. Well, when you multiply that, 3 times 1/3 is x, 3 times 1/3 here is 1, and then you've got the minus 1, so you just get x. Now if you turn it around and go the other way, and do g composed with f of x, then you take this function and you replace x with this over here, 3x minus 1. So if I do that, I have 1/3, I replace x with 3x minus 1, and then I have plus 1/3 out to the side of that. And then when I distribute, 1/3 times 3x is x, 1/3 times minus 1 is minus 1/3, and then I got to add this third to it, so the 1/3 and the minus 1/3 cancel, and I just get x. Okay, so it turns out that for this particular pair of functions, f composed with g of x and g composed with f of x are the same value. They're both x. Now, when that happens, you've got a unique relationship between these two functions. It turns out that when that happens with two functions, those two functions are inverses of one another. And you could actually show that f composed with g of 3 is 3, and you could show that g composed with f evaluated at 3 is also 3. Well, actually this is true for any number, and thus these functions are inverses of one another. Because see, what happens is, like, you plug 3 into the g function and it takes it somewhere, let's just say question mark, and then when you plug that question mark number into the f function, it's going to return it back to 3. Let me show you that. So let's say I took the g function and I evaluated it at 3. So here's the g function. If I put 3 in, I get 1/3 times 3 is 1 plus 1/3. So I get 1 1/3, which is 4/3. So I would get 4/3. But then let's say I put that 4/3 in the f function. Well, then I would have f of 4/3 would be 3 times 4/3 minus 1, which would be 4 minus 1, which is 3. So see, when you do the composite, you take the g and evaluate it at 3, and then take that result and evaluate it at f, and evaluate it for f, it's going to take you right back to 3. And so basically what's happening is, it's whatever f is doing to x, g is going to undo that, and whatever g does to x, f is going to undo that. And that's kind of what inverses do for one another. One will do a set of instructions, and the other function will reverse that set of instructions. And we'll talk about inverse functions in the next section.